Hey guys, here's a video finishing off that problem from class, doing a curve sketching problem from scratch. So you've got yourself your function, of course, and we want to pretty much take this all the way through, see what this graph looks like without actually putting it in the calculator. So one of the first things I said to do would be to find any intercepts, just to try to lock this graph in. So if x is 0, of course we get 0. So I know 0, 0 is on the graph. Unfortunately, if I set y equal to 0, the only value for x that would make it 0 would be 0. So this is the x and y intercept, and there are no other x intercepts. Then I said, how about asymptotes? So we can look for vertical asymptotes. That would be at plus or minus 1. So at negative 1 and positive 1, I have vertical asymptotes. Great. Horizontal asymptotes, I'll take that limit as x goes to plus, or minus infinity. I notice the powers are the same, so the asymptote will be located at the ratio of those leading coefficients, so that would be at 2. So I have a horizontal asymptote at y equals 2. And now I pretty much have this sectioned off to where the graph is going to live. It's certainly going to be down here, and then maybe here or here, and then maybe here or here, and we'll see kind of what happens. So we've got our graph locked in with our intercepts. We've got our asymptotes. Now we can check for when the function is increasing and decreasing, try to narrow this thing down. So if I'm going to do increasing, decreasing, I need a first derivative. And to do that, on this one we need to do a quotient rule, of course. So I'll do a quotient rule. I'll just kind of run through it. We've seen this many, many times. So I'm just going to kind of do it real quick. If you need to pause the video, match up yours to mine, obviously that's fine. So leave the bottom alone, derivative of the top, minus leave the top alone, derivative of the bottom, and clean that up just a little bit. If I clean that up, I get 4x squared minus 4x minus 4x cubed. Okay. And then go ahead and clean that up. And, wait a second, that should be 4x cubed, right? 4x times x squared, of course, is 4x cubed minus the 4. Okay, so conveniently, that takes care of that. And we're left with negative 4x over x squared minus 1 squared. So there's our first derivative. And it looks like the denominator here, obviously outside of plus or minus 1, where the critical values are, is always positive. Okay, so really just the numerator that's kind of dictating the sign of my first derivative. So critical numbers are plus and minus 1, and of course that's 0. So let's just check. If x is negative, this numerator becomes positive. Divided by positive is of course always positive. So except for at negative 1, left of negative 1, right of negative 1, all the way up to 0 will be positive. So my function looks like it's increasing when x is less than 0, as long as x isn't negative 1, because of course that's when it was undefined. And then of course to the right, I have x is positive, which makes this negative over positive. So that's negative and negative. Okay, so my function is increasing all the way to 0, then decreasing. Looks like I have a local max at 0, 0. We already knew 0, 0 was on the graph. So this is going to be a local max. So my guess is it's going to be something like this. I know the function's increasing all the way up to 0. So if I'm going to be increasing, let's just focus on to the left of negative 1. If I'm going to be increasing and I have to approach this horizontal asymptote, I can't do that from down here. I have to be doing that from here. So I'm going to be coming in, I must be coming in this way, increasing, which means I got to be going up towards that vertical asymptote. I'm also increasing from negative 1 to 0. So that means I must be coming in from this way all the way up to here. And then after that, I must be decreasing everywhere else. So I'm going to be going down this way, all the way down to that asymptote. And of course, if I'm going to be decreasing on this side, I have to be approaching that asymptote, so I must be coming at it from this direction here. So far, that's my rough structure of what's going on. Sometimes something funky could be happening in here. Maybe that's increasing, and then it does some kind of little flattening out, and then it increases again, although I'm guessing it's probably not going to flatten out because I don't have any other critical numbers. But it's really a good idea to always just check your second derivative for your concavity. Just make sure that this makes sense, and occasionally there is something hiding in there, so you really should look for it. So we need a second derivative. So I'll do that right over here. I got to do another quotient rule, of course. So that's going to be to the fourth now. Leave the denominator alone. Derivative of the numerator is -4 minus, leave the numerator alone. Derivative of the denominator, I got to do a power rule with a chain rule kicker. So that's 2x squared minus 1 to the first times the derivative of what's inside. And we got to clean that up a little bit. So this is all over x squared minus 1 to the fourth. It looks like, actually, before I go that much further, it looks like I have an x squared minus 1 in both terms here, both expressions on either side of this negative. So I could really factor out an x squared minus 1 and then cancel it out down here. But just to save space, I'm just going to cancel it out now and make that 3. Okay, so I have an x squared minus 1, x squared minus 1, that comes out, cancels out with one of the x squared minus 1s in the denominator, and that leaves me with -4x squared plus 4. And then this becomes positive 4, 8, 16x squared plus 16x squared. And that turns into 12x squared plus 4 all over x squared minus 1 to the third. I guess I could take out a 4. 3x squared plus 1, just to make the calculations easier, over x squared minus 1 to the third. So that's my y double prime. So I'm going to set up a number line for my y double prime, critical numbers at -1 and +1. Looking at the numerator, that's 3x squared plus 1, right? So if that's plus 1, I can't get an x value to make that turn into 0. So I don't have any other critical numbers here. Okay? So this is always going to be positive. That's always going to be positive. The denominator can switch, though, because it is cubed. So we do need to be careful here. If x is -1 billion, this is really, really big positive. -1 doesn't matter. Cubing it's still going to be positive. Then between -1 and 1, how about 0? That's going to be positive. That's going to be negative, so that's negative. And then positive 1 billion, I'm at positive over positive, which is positive. So it does look like I have concave up, concave down, concave up. I know that concavity does change signs, you know, at -1 and +1, but of course we don't have points of inflection because the graph isn't even defined there. Okay, so I do go from concave up all the way to -1, so that kind of makes sense. That matches what we had before. Concave down from -1 to 1, okay, that makes sense. That makes sense. And then, of course, concave up again after, and that makes sense as well. So it looks like my graph is concave up, concave down, concave up. I have a local max at 0, 0. I have increasing, increasing, decreasing, decreasing. I know I didn't draw it so well. I didn't do it on graph paper. I probably should have. No points of inflection because it's not defined at -1 and 1. No local minimums. And I think that's pretty much it. Okay, let's take a look on the graphing calculator just to make sure it's reasonable. This probably is going to come closer just because my scale is a little different, but let's just see. Is that this one? 2x squared over, yep, that's it. Let's check my window. Yeah, that's probably good enough. See what that looks like. Okay, so concave up, right? Concave down, concave up, local max at 0, 0. These lines, my calculator doesn't, you know, it's sort of glitchy when it tries to do asymptotes. It's trying to go from here down to here and connect it. It's not too smart, but these are just asymptotes. That's not, oops, that's not actually on the graph. So up, down, up matches pretty reasonably to what I have here, and that's pretty much how you have to do it. Okay, so hopefully that helps. I know we had gotten through some of this in class, but we didn't get to finish it, and you just kind of got to grind it out. Find the intercepts, find the asymptotes, find increasing, decreasing, and local maxes and mins, find concavity and potential points of inflection, and that pretty much gets you all the way through. All right, hopefully that'll get you through the homework. If you have any other questions, please don't hesitate to ask, and I will talk to you guys soon. Bye.